Does everyone see the canvas?
Yes.
Yes,
Sure.
perfect.
Yes.
Now, Walter, let me go ahead and tell you how to get the chat to be able to pop up as well, and then you can determine if you want people to send you chat or ask you questions.
Oh, yeah.
To get to see the chat to populate on this screen, if you move your mouse up to the top, you'll get a bar that drops down, and at the end of that bar, you'll see a button that says More, and there's like 3 dots.
Okay. I see a column. I have a column. Yeah. Okay. It says mute 3 columns. Stop video, pin video. No, I got a grid. Show grid video. I don't know what that is. Show small active speaker video. Hide thumbnail video. Oh, wait, there's a bar at the top here.
And click on More.
Oh, there we go. Yes. And chat.
And then you click on chat, and then I'll send you a test chat real quick just to make sure. Yeah. Good morning.
There we go.
All right.
And I'll just, did everyone get that?
It
All
is
right, I'm
true.
going to see if I can move this over to my other screen here. And that seems to be working.
Yep, one of the things that I've been struggling with is how I want my screens to be set up when I'm doing Zoom so I can see people and at the same time be able to see my screen.
Okay. So LaTeX now, if you go online, you can you can find this list of LaTeX symbols. So you can see, whoop, that's not working the way I wanted it to work, okay? But you can see that you can get a lot of math symbols with these commands. Now, the basic idea is if you enter in, for example, this command here, gamma, you will get this Greek letter gamma here, capital and lowercase. And you can see you got all the Greek letters and all of their variations. Then you have various symbols. See, now if you want less than, you can just type the usual less than. But if you want less than or equal, you'll type something like /LEQ. A LaTeX command is always prefixed with this \. And you can see that you have a whole bunch of commands here that you can use. This will all appear in your document. Okay, this is only a small cross section of them. These are the basic ones that are pretty much available all the time. Okay, now if you want actual document, there is a document online, the Not So Short Introduction to LaTeX. Now this, of course, is designed if you want to actually do a document, but it has a section. If we go down a bit, it has a section here, typesetting mathematical formulae. And then it has also a list of mathematical symbols in section 310 as well. And you can see a whole bunch of symbols again. And now you can see this one in particular, for example, plus minus, like in the quadratic formula. We're going to do that in a few moments. But you can see all the symbols you can get are available in LaTeX. Okay, so let's get down to some actual. I created a whole bunch of questions here and topics, not necessarily in any particular order, but okay. So anytime you start a question, right, you click your little pencil for edit, and then you have the body, the basic panel here to create your question. To access LaTeX, you click on the square root. And if you do that, you get another panel and a toolbar. you notice you get a nice toolbar, and it has all of these symbols available to you. Now, this is the basic view. The one I prefer to use, and I'm going to teach you mostly, is this advanced. So if you want a square, you just do like x squared. And you notice that you get a nice little preview of the power. Now, if you have two powers, you can just do like this. And if you're done, if you like that, you just click insert, and there it is. And if you highlight it, you can actually change the size of it if you want. Okay. So those are powers. Now you can do it again. So if you change, you have to do it every time. Unfortunately, it's not fully integrated. So you need to, every time you want to do something LaTeX, you got to click the square root symbol and get to the panel and so forth. Now, if one thing you need to keep in mind is if you have, I think I get this right. So if you have, there's a command C dot that allows you to separate powers. And again, you can see what that looks like. That allows you to put a little dot if you want to separate. Okay, that's C dot command. And if you put your mouse over it, it will give you the formula, will be highlighted. Okay. Now, the next thing you might want to do is, like if you're teaching, is suppose you have a group. So suppose you, if you, oh, I need to type, click the little square root thing. Okay, now, so suppose you want to do something like this, x squared y to the fourth, and then say to the fifth power. Okay, now that looks okay. Let's blow that up a little bit. Okay, and that doesn't look too bad. But sometimes if you want to be a little fancier, we'll see if there's any difference in this case. What you can do to get an adjustment, you can make that parentheses dynamically adjustable. LaTeX will figure out what's inside and what the proper size of the parentheses will be. So if you do left and right like that, and then put a fifth power, okay, it looks like it's pretty much the same in this case. All right, but we're going to see a little bit later. Well, I guess we can do it now. Okay, so does that make sense? Is that good for just powers?
Mm-hmm.
Or you might do powers? All right, so I'll just update the question. And let's see, let me move down. Linear systems, equations, limits, derivatives. Okay, well, let's go back to the power here then. Let's go back to this question for a second. And let's talk about radicals. Okay, so if you want to do radicals, now your typical radical is backslash square root, say, of x. And then suppose you want to multiply that by, say, the cube root, then you put it in brackets, and then curly brace. The argument of a LaTeX command is always in curly braces. Okay, and now you can see that gives you a nice cube root. Okay, Now, if you want to put that over, let's say you want to put that all over a common radical, say you're multiplying those two, right? That's a common problem. In a multiple choice, one of my multiple choice questions was answering this. So you'd go something like left, and then you could do x, what would it be? X cubed. What did I write? X to the, just xy was a cube root of y. And that would be squared, say, right? And then you want to balance that with a right, and then curly braces, 1/6. And you can see again that it will balance everything. The parentheses will be dynamically adjusted for the size of the expression. Okay?
Mm-hmm.
And that's how you can do radical. So that's how you access. And of course, that cube root, that can be anything. That can be fifth root, fourth root, any other kind of root you want to do. Okay? So those are radicals. Okay, all right.
I had a question.
Yep.
Can that 1/6 be written in vertical mode instead of like horizontally? So like 1/6 straight up and down?
Yeah, and if you want to re-edit a command, okay, well, that's not available. Once it becomes a graphic like that, it becomes a bit, oh, I need to click edit. Yes, you can. Well, if you want to do fractions, I'll do it as a, let's see if I can access this. Okay, good. Yes, now if you want to do it as a subscript, that was what you do. What you have now, you can always give yourself some space to work too. Don't be afraid to space a little bit in a bracket, in closed brackets like that. Now, it's called display fraction like that, defrac. And so if you do 1/6, you can see that it will in fact do that. Okay, but that's typically if you want to create, let's just do another edit. Let's just create something more complicated. And
Thank you.
if we want to do, if we're doing something in calculus, say x squared minus y squared over x squared plus y squared, right? This would be the sort of thing you do to, in say, third semester calculus. And you can see that you can create quite complicated, any sort of LaTeX, anything that LaTeX can itself display, you can put inside the argument of a display fraction. So you can, so if you want to be crazy, just for the heck of it, just to show you how ridiculous you can be, I'll give myself a little bit of room there. And then I want a denominator, and I'll give myself a little bit of room. So let me do something like this. This ties into what we can do later. N equals 1 to INFTY infinity of 1/n squared. Okay. And then why don't I do the product of one minus p to the k or something, negative k, right? And then if you want negative, you need to make sure you put it in braces. Okay, but now I can put subscripts here if I want, and I can go k equals 1, and I can go to infinity again. And then I can insert the equation, and you see it'll do it without any trouble. Okay, so you can do very complex constructions without any trouble whatsoever. Okay, And you can do fractions within fractions. You can do powers to powers. Now that's something we hadn't done. You can go, okay, I need to go to the LaTeX again. So if you can do x to the x to the x without any trouble. Also, things like that. You see? So LaTeX is very robust and can do very complicated constructions without breaking a sweat. Okay? This is how you do it. Okay, and I'll export this. I'll try to make this available. I'll export this quiz so you can look at it. Okay? Now, the use of the text command. All right, now sometimes, once upon a time, occasionally you'd want to have text within a math equation, and they don't render properly. Let's look at the difference. Okay, here is and then next to it, I'll put and you can see that it's different. The spacing, the thing is that LaTeX will treat the A and D like math variables. Each A and D is a separate character, is a separate variable. The text will allow you to use text within a math formula. Now, why would you want to do that? Okay. So you can do it like this. And you can put the whole thing in text, by the way. And now here's something that is commonly done. Give myself a little bit of room to maneuver. Okay, I can go like this. I can just say backslash sigma of n equals, and then, okay, and now maybe you want to create a little bit of space and say the sum of divisors of n. Now, within LaTeX, the document typesetting language, anytime you're within a paragraph, okay, that's not doing it. Okay, so we'll just leave it. Okay, the way you say, I want something to be rendered as mathematics, you enclose it in dollar signs, and that makes it rather, instead of just an n, it makes it a mathematical n. Okay, dollar sign, you enclose it in, whoops, okay, a little too. Okay, so then when you insert that, and then there you go. Okay, the text command is very useful for this kind of definition. Yeah. Otherwise, it would look very poorly. If you didn't use text, it would look, well, it just look bad, just plain bad, unacceptable. Okay. There's a text command, very valuable for this kind of construction, okay? All right, sums and products. Now we just did something like that. Just I kind of jumped the gun. But now, like I say, if you want to do a sum, a sigma, say you can do, so backslash sum gives you the summation. If you want your subscript, you put curly braces, underscore curly brace, and then you say something like k equals 1. That's your lower, like a power. A superscript would be like a power. K equals 1 to n. Now, what you typically might want to do is, even if you don't have to, always put it in curly braces. You never know when you might need them, and it's a pain to put them in as an afterthought. Okay, then you can do K, and then what's the formula for this? N times n plus 1 over 2. Okay. And there you go. And you can put it in the middle if you like to align it. Now, one thing you want to notice is the sigma, is the size of the sigma. Notice that where the subscripts are. Okay, there. That's like a text sigma. Okay, now let me just grab that again and go make another one. Now I'm going to show you what you can do differently. There's a command display style that forces now notice the position of the subscripts and the size of the sigma are completely
Right.
different. That's more like a displayed equation sigma. That's more like what you really want when it's in the, that's more the kind of form you really want if you're going to put it in the middle like this. Okay, is use this display style commands to make it render properly. Otherwise, it'll render the way you see in the other one without it. Okay, so let me go home here. Okay. Okay, so that's sums and products. Now, if you want to do a product, there aren't that many product formulas. I don't know one of offhand, actually. If I get this right. Okay, well, let me leave that for a moment. So dfrac 1 over 1 minus p to the minus s, I believe, right? Now you can do text within here. See, you can go, and now you can say, if you want. And there you go. Okay, and again, it's the same story. If you have the same formula and you, now one thing you want to notice is that it's if you make a mistake, it won't display properly. So you'll know there's a mistake somewhere. You put a bracket where you should have put a curly brace or something like that. It won't render if there's a mistake in there somewhere. Okay. But now you see that the subscript on the product symbol is now a very much larger, and then it's put on the bottom. So that's the difference that the display style makes. Okay, makes a very significant difference. And this is probably what you usually want. This is what you might get if you're not careful. Okay, so display style is very useful in doing that. It's also important when we do integrals. Also, same thing with integrals. Okay, you want me to go to integrals first or matrices? Linear systems, rational expressions, what do you want first? Trigonometry, integrals, equations. I did some chemistry last night. I looked up some chemistry if you want to. You have to work a little bit. You can use math to do chemistry too, if you like. It doesn't, there are packages to do chemistry in LaTeX, but Canvas doesn't support inclusion of any of that stuff yet. Maybe someday you might. What do you want me to do? What's on your, anybody have, okay, how about,
How about piecewise functions?
Well, boy, aren't you just a sharp.
Sorry.
Okay. Yes, you can. Piecewise functions.
Oh,
So
integrals when you get ready, when you get done.
let's see. I haven't done that yet, but that's good. Okay, there is an environment. This is LaTeX.
Piecewise, yes, I want to do piecewise too.
It's called, LaTeX has what are called environments. And so begin and end, and within begin and end, you can do various, it will do various things for you. So you can do cases. And now if you do say, let's say e to the x, and then you put an ampersand, and then you want to do text. See, there's your little text command. And you say, then you can say if, say, $x less than -3, say. Or how about x less than negative log, well, let's not be too fancy, okay, -3, okay, and then depending on conventions, you usually can put a semicolon. Now, if you want to move to the next line, you put double backslash. That says you're going to have a next line. Okay, so I'm just going to cut and paste this so I don't have to do a little bit of typing. See, and then if you have another one, then you can do, say, what do you like? Okay, let's log of x. And then you can say if x, so then you can change your inequality, and you can, well, I can't do that, right? Okay, I can do, yes, I can do, you pick bar, say, and I can't go past 0, right? So I can still do -3 less than or equal to x less than 0, say. And you notice, oh, I deleted something there. But you notice now it's doing it. Okay, and then you can say, say, square root of x ampersand. And then you can just like that. Let's see, do I have everything? And then, of course, you can get, when it's the last one, you get rid of that, and then you can put a period. And the
Thank you.
Okay, and you notice that the curly brace there will automatically size for however many you have. Okay, it'll get as big, and they can be huge. In LaTeX, the brace sizes can be half a page almost. They can be really big. I mean, well, maybe I'm exaggerating, but close enough. Pretty couple inches easily in size that LaTeX will render them. Okay, there you go. So let me back up and let me just subtitle that so we. And yeah. Okay, that's how you do that. Good question. All right, anything else you suddenly occurs to you? Okay, let's go to something like a linear system then. Let's go up to linear systems, say. Okay, so let's just make something up. Okay, make with solution, say 1, 1 or something, so we can do it. Okay, now there is another command in LaTeX called the array command. Okay, now if you want this to display properly, this is the way I look at it. Each column can have its own position. You can put things on the right. The entries can be oriented to the left. They can be centered. They can be put on the right. So when you do, when you're doing a linear system, let's just do a 2 by 2, RC, RC, R. Okay. And then you need to end that. Okay, and let's just go 3x, then separate it. Put the plus sign, separate it. 2y, separate it, equal, and that would be, say, 5. Okay, so now let's go to the next one. Does that do it? R, C, R, C, R. Good, yes. Okay, so I'll just grab that. Sorry about that, I didn't get the right position. Okay, and then you can do something like 7, -7 plus 11y is 4. You know, what did I get wrong? It may not like that space right there. Yes. Okay, see, sometimes spaces do matter, sometimes they don't. But now you can see with this array command, and if you put like, say, well, let's try, okay, you can see how that renders. But if I do, say, negative, and then that would be, say, -4. And there you go. Everything lined up. Okay, and of course, again, you can put anything at all in a matrix. You can put fractions in here and everything, just like you had before. Okay, you can have linear systems of intersections of ellipses or something like that, right? There's no reason.
Walter, do we also use the array function for matrices?
It depends on what you're trying to do. So let's go down to let's do that next then. Okay, it depends on what you want to do. Matrices, okay? Now there's a whole bunch of, see, that's why I have them, okay? So if you want to do, let's just do 2 by 2, of course, to keep things simple. Now, if you want a different matrix, you do B matrix, begin. See, again, LaTeX have these environments, and there's a whole bunch of environments of all kinds. Okay, so there you go. And now if you want, say, -2, you separate with ampersand, and then you start a new row, and then you go to 5, say, -12, and there you go. And the default is centered in these kinds of matrices. In these environments, the default is a centered, okay? So now, okay, so that's with bracket. Now, if you go and you say P, you get parentheses, if you want parentheses, okay? If you want bars, then you change that to a V. Oop, I'm obviously doing it again, right? And you have bars. Okay, now if you want double bars, you have to use the array command with double bars on it. Okay, we won't get into that. We could do it, let's see. Oh, well, okay, let's move down. We'll try that later. But now if you want to do something like an augmented matrix, okay, now that's a little bit trickier. It can be done, but let's just do a 2 by 2. Now you're going to want to use your, you can use your left and right, but they don't have to be the same symbol on the left and the right. Okay, now I'm going to move that down a little bit and get that out of the way. Okay, because in between here, I want to go up one more. I want to put an array. And of course, here you can decide which way you want them. If you want everything centered, you can put centered. If you want them right, which sometimes you might think you can do anything you like here. Okay. And once you do that, see, now you can do -2, 3, 15, e to the pi. Okay, and you see it's doing it. Now, what you want to do now is do another array right next to it. And so now you do left, but you don't want anything there to say you put a period. And then you can do right with a bracket. Okay, and now you just create an array, a column. You just create a column. And maybe you put it to the right like that. You see, it gets a bit complicated, but you see once you get the hang of it, it can be very simple. And then you can use a Greek letter. Let's just put Greek letters in there since we're playing around. Then you can see you have an augmented matrix. Okay. Isn't that pretty? Okay. And of course, if you want determinant, of course, the bars also mean determinant, right? That's typically what the bars mean. Okay, but let's change that to say B. And of course, there is DET. That'll render like determinant. Okay. So there you go. Now you can put subscripts on these. There's nothing to say that you can't take something like this and put a -1 on it, like that, as an inverse. Okay, you can put a subscript. You can put, and of course you can put subscript on it too. Like if you're evaluating in an integral and you want to have a lower limit and upper limit, you can do that for evaluating an integral. If you want to do that next, we can do that next. Okay.
Someone asked for integrals in the chat, so I think that's good.
Okay. All right. Oh, I wasn't looking to the. Oh, okay. All right. Okay, good. I should look over to my left there. I wasn't looking. Just remind me. Yeah, remind me if I'm being okay. So integrals. So down here. Okay, so let's do an actual, like a quick little calculation then. Okay, so your basic symbol is int, like that. And then you want to go say 0 to 4 and say x squared dx, right? Then you can do, now you want to do left and right. And then you can go 0 to 4 like that. And now decide how you want to put it. So you say, okay, do d frac x cubed over 3. And there you go. Okay. And then, of course, evaluate from there. You can evaluate. We won't bother with it. Okay. But you can do it just like that. And of course, this is behaving just the way you'd like it. There is also a display style for integral, but it doesn't seem to be necessary in this case. It seems like it's just the right size, exactly the right size. Okay, now if you're doing double integrals, you do double I. We'll do a double integral. And then you can do like integrating over a region e to the xy dy dx. Okay, now sometimes if you see the dy dx doesn't separate that well, now here's a little lesson. There's a backslash. Let me get I installed a magnifying glass. Okay. There we are. Okay, you see that backslash comma? That's what's called a thin space. That'll put a little bitty space between the dy and the dx to make it look better. Okay, and you see that there is one. If you look, okay, and if you doesn't make it easy on me, does it? Okay. Well, anyways, we'll insert the equation and then we can just blow it up. And you see there's that nice little space between the dy dx. Otherwise, they'd be just smashed together. Okay, now that isn't in display. You see that? That's kind of like a text mode. It's the same thing. And now it's a real double integral type thing. Triple integrals, same idea. Okay, let me just grab onto that. And of course, it's 3i's. 3i for triple integral. See, so that'll do that. And of course, you can break these up. You can put the integrals together next to each other, right? If you want to see, this one needs a display. You see that one, this one right here, the first one I did, you can see how that needs a display style in front of it. See the way it's rendered? Okay. What did I want to mention? Yeah, you can put them together. Okay, this may not make any sense. Integral, say 0 to 1. Okay, let's just keep it integral 0 to x, say. Whoop. I need my 0 to x. And then you can do, okay, x, y, dy, little thin space, dx. And then, of course, just to make sure it looks the way you like, And get rid of those. And there you go. And now, of course, again, you can see that you might want to put a little thin space there too, between the X, Y. And there you go. And that's how you can make a nice double integral. Make use of those thin spaces to make it look good. Okay. And of course, you can put any kind of subscript you like. So if you want to, there's nothing to say that you can't do something curly braces and then do square root. Say, nothing says you can't do something like cube root of x or trig functions, e to the x, log x, anything that you want that you have to put in there. You can put superscript, subscript. It'll render just fine. Okay. All right, is that good for integrals? Are we good?
Walter, what about, say, a line integral for flux or something?
Oh, yes. Okay, let's see if, well, it all depends on whether Canvas will render it. That would be OINT. And it does. And there you go. And you could put you know, something like that.
Okay.
Okay. And then flux, you put double.
Okay. Cool. Okay, I was just going to ask that.
Do that. It should do something like that. Maybe it doesn't. Maybe it just doesn't do the double flux integrals, because I think you should be able to do that, like O trip double.
Right.
It should be able to do it. Like I say, I found occasionally the Canvas doesn't have absolutely everything available. But
Walter, does it allow you to show orientation, like clockwise or counterclockwise on the closed path integral like that?
Yes, there is. You'd have to look it up on I think there are special packages, a little font set you need to read into your document. For example, if you were typesetting a document, you could look that up, and there'd be a special package that might have that, and then we'll have the orientation, like counterclockwise or clockwise orientation. It'll have a little arrow on the symbol. Yes, it can do that in LaTeX itself. There are a huge number of symbols of any mathematical thing you can just about think of has already been considered and implemented by now. Very wide range of symbols. And so, yes, there is one where you can indicate the sense, but Canvas may not have it. And I don't have it off the top of my head, actually.
Okay, yeah, thanks.
Okay. All right, good. Let's see, where are we? Yeah, so the difference between, if you're doing integers, so you have the two different basic display modes. Now you have, we can talk about several, okay? But the one that you're interested in is like math. So there's bold Z, and then there's Blackboard bold, like that. And so let's look at the difference. Okay, that's your difference between the different, and then you can do these with all the letters. It's not just Z. You can put A through Z in those commands. Okay, and if you want certain kinds of text in a, if you want to have something more sophisticated, like say in a math equation, say you could say trace of matrix equals 3, say. And you do math, RM is Roman upright font. If you like italic, it will make it like an italic. Okay, but typically, of course, the convention usually in such cases is Roman font. Okay, and I don't know if we'll do it. I think there is an SF, and it does that sans serif. If you want to be even more specific to make sure it's a real mathematical trace, it's really okay to make it explicit. You can sans serif it. Okay. Also, so there's also math SF, math italic also. Okay, they have different effects like that. Okay, so that's how you can get those. And you can put whole expressions within the math Roman. So if you, let's just do that again. And you can put whole expressions in there. And you can see they're upright. So you can see they're upright rather than italicized. Okay. All right. All right, what else do we have? Rational expressions, I think we did some of those. I think I've covered those with the defrac command. Trigonometry. So you can do all of your usual you say. So I have all your nicely rendered trig functions. And then of course, there are all the usual ones. Of course, 1 plus okay. Okay. Then you can do your inverse. Now to do your inverse, you just do a superscript with -1. Like that. And of course, if you want to change that, now what you want to do, and of course now you can also do arcsine if you like. Right, and you can do defrac. Okay. And there you go there. Okay. So you can do arcsine, arctan, all the usual in the same way. Okay. And of course, if you prefer, if I didn't screw it up, maybe I did. It's hard to read. I think I screwed up my braces here somewhere. Let's see. Yeah. Right there. And then
Is
okay.
there an undo with the Canvas editor?
No, that's horrible. It's horrible.
It is horrible.
Okay, so what I need to do, see, this is where you give, oh, there we go. Yeah, I think that's it right there. Okay, and then of course, then you can do that instead, if you like. It's a little bit more complicated, but you can see you get a very nice result. Okay, so those are all your trig commands. And then just for the sake of argument, you have, of course, your e to the x and your ln of x. Also like that. And then, of course, you also have basic log symbol, and you can, like that. And if of course, if your base is anything complicated, put it in braces, and you can do log base pi over 2 of 23 without any trouble. Okay. Well, where are we? Oh, okay, we can keep going as long as everybody's cool. We can keep going. And so limits.
But is there some way that you can show not only the equations, but how you get there, for us?
You mean like derive them?
In other words, you're showing how to do it, and then you're pressing insert equation, and we see the equations, but it would be nice to see something with what you did, typing what you did.
You're not seeing the actual text I'm entering here. You're not seeing the text here. Like
Yeah,
this?
I am, but then I have to memorize it.
Oh, well, this will be recorded, so hopefully you can get the recording. We'll see if you get the recording, and you can then play it
In
back.
the recording, I will see the text.
Yeah, you should be able to see everything. And hopefully,
All right.
Walter?
that's what I was asking. Okay.
yeah.
Also, Walter, did you say you were going to share this, you were going to export this quiz so that we could like import it into a Canvas shell and have access to all the editing you did in there?
I'll put it on the shared drive. Email me and I'll send it to you. I'll put it on my shared drive and send you a link.
And then we can just import it into a shell that we have for playing around, and we can open it up and play around with the commands in there, right?
That's right.
Okay.
We might be able to
Thanks.
get Polly to put it on the CTLE website, like the page with the recording and then the exported quiz.
Okay, that's even better.
Yeah, and Walter, if we email you, what is your email address? Because I'm gonna have to log off here in a minute, so sorry to ask all these now.
Walter.kichowski@gccaz.edu.
GCC AZ.
.edu.
gcc.az.edu. Okay, thank you very much for this, by the way.
Sure, sure.
So Walter, we have to be in that advanced view in order to be able to make the equations.
Well, if you do it, okay, well, see, if you do it, if you do it in basic, okay, what basic is basically going to do is you click up here like this.
Okay.
And then you would do 5 and then 4 and things like that. Now, what I found is that this does not render as nicely as this as if you do it from scratch. Let's see if we can do it. Let's see what I was talking about. Now, suppose I want to do like the quadratic formula. So I would do something like this. I would come down here. Okay, I got 2a here. And then I do minus b, and then relationships, let's see, operators, miss, where does he see? Now you need to find it.
I think it's in basic.
There it is right there. Okay, no, that's just plus, and okay, so there you go. So let's go back and get rid of that. And then we can do square root, see, and then b, or you can do like that, squared, drop down, and then minus, and now it's easy for AC. And there you can see you can do it. Now, so let's blow that up a little bit. And now let me nope, see see now if I do it, say PM square root, and oh, I see it. You notice that it's better.
Yeah.
The
Yeah,
equality,
there's like more space, right? Like in between, and it just looks cleaner.
it's more naturally rendered the way LaTeX would render it. Say if you
Okay.
do it in the basic view with that, it will not render as nicely.
Okay.
Pointed that out from the beginning. Yeah, so that's the reason I was doing the advanced from the beginning.
Okay. Thank you.
Yep.
And how did you get to the advanced instead of the basic?
Whenever you click the square root, you have the right here, the toggle right here.
Great, thank you so much.
Okay.
Thank you very much, Walter.
Okay. All right. I guess
I have to get going. Sorry.
signing off. Okay.
Learned a lot today.
You can
Yeah.
see how I can go. Keep going.
I
Okay.
had one other question, Walter.
Uh-huh.
Oh, limit.
Do you ever like do your editing in a different like LaTeX editor and then copy and paste it into Canvas so that you don't have to deal with the fact that there's no undo button in Canvas?
I'm usually, this is on my tablet.
Oh,
So I can't see it as well, but if I'm on my computer, my main big computer, you can see it a lot better. If it's on a bigger screen, it's not as bad.
okay. So you just always work right within Canvas then?
Yeah, it's not as bad. I haven't had to do that
Okay.
yet, but that could happen, but it hasn't happened yet.
Okay, thank
But-
you.
On a bigger monitor, it's not as bad.
Walter, have you used the, so like have you put an equation into the answers? Like use the
Yes,
LaTeX
yes,
in,
so see if you do that, it's not as bad. It's the same idea. You go to your edit, it opens up, and then you click your square root, and then there you go. And it just puts it in there just the same as usual. You just click edit, go to that, click the square root, enter in your equation, insert equation, then click done, and it will be inserted just like everything we've been doing.
awesome, thank you.
Walter, can you quickly show some derivatives very quick?
Where did I have them? They're around here somewhere. Piecewise, vectors, row, there we are. Yes.
Limits after that?
What's that?
Can you show limits after that?
Okay. All right. So, well, I can do both at the same time. I can do a couple at the same, I can do both at the same time. How's that? So you can do something like df dx as a fraction, say, and then you can say, so there you go there. So limit, and then you can say h. Now here's that right arrow, 0. Okay. And then of course, you can have h, and then you can have x plus h. And there you go.
Great, thank you, appreciate it.
Or something like that. Now, if you do partial derivatives, I'll just show you the basic. It's still, again, dfrac. But if you do something like partial to the 5f, you can do
Okay.
partial x squared partial y cubed.
Oh, yeah. Okay.
Yeah, that will do, thank you.
What, and if you do display style, that will show the limit, that you had underneath on the other one?
That's
See,
right. That's right. That is exactly right. So if we go back,
where would you, oh, right, very beginning, you
right
put
at the
display
beginning,
style. Yes, okay, yes. Thank you,
there you go.
thank you.
Yep.
Display style.
And I did a few other things here I entered in. I was going to do that separately, but it doesn't matter. All right. Anything else? I can do one more. So let's see, equations, we kind of did that. Let's see, we really did a good job, didn't we? Okay, now if you want to do from the left, say, just a quick example. Now, of course, let's just start from the beginning. Now you do lim, of course. And now if you do X, right arrow, and then say you're going from the left, you can put superscript negative on it like that. Say, and that'll give you, you can put plus, and you can put a superscript plus there too. That'll make it a limit from the right. Okay. So if you want to, and you can do even more complicated subscripts in LaTeX. There are other more. And there you go. From the right also. Okay. All right. Any last minute questions? All right. I thank you for attending. It's been fun.
Oh, yes. The display style makes, like, if you have a single integral, you can make that single integral large from left to right.
Right. So look at this one right here.
Yeah, that's the one.
Okay. See, so if you look at that, so let's edit that.
Right.
See, so now if you highlight it, see, then you can automatically edit it. And now
Oh, okay.
if we go to the end,
Display
getting
style.
it there, and now
Insert.
and there you go. Now it looks like what you'd really like it to look like.
And then you can make it larger.
Right.
You can show me how, and you just click on it to make it larger.
Oh, yeah, once you do that, it's a sizable graphic. You can just grab the corner.
Right. Okay. Yeah. Yeah. Yes. Thank you. And I guess one last question is, what if you have 3 graphs? You know, any graphical? Does LaTeX do the graphs?
I was gonna, I don't, well, there, it depends on what kind of question you're asking. How do you include a graphic that you already have, or how do you can, there are more sophisticated packages that if you have a LaTeX system on your computer,
right,
you can use to generate your own graphs.
Oh, okay.
And then you can generate them separately, and then you can drag and drop them into your document. That's a whole other thing. Then you have to want to be committed to learning, not only getting a LaTeX system on your computer, but digging into the programming of how to generate a graph and all that kind of stuff.
Oh, okay. All right.
That's a bit harder. It depends on where you want to get your graphics from. Something. Okay.
I might have it from, let's say my quiz or my test has a graph in it, and I'm trying to copy and paste, and it's difficult.
Yeah, okay, well, you can cut it, right, okay, right. Well, you cut it and can save it and then include it because you have your, oh, okay, well, see, there's this.
Yeah, that's good. Right.
Embed image.
Right.
And I don't think I have any real images on this computer yet.
Oh, okay. Okay.
But you can include, if you click that, you can include it. Now, what you can do, if you go to Canvas,
right,
what you can do here is if you have it on your computer, you can click where you want to put it.
Right.
And then you click upload and
right.
upload it in, and then you can set dimensions, aspect ratio down here.
Oh, okay.
And then when you upload it, you go to your browser, you search on your computer where the image is, and
Right.
it'll upload it into Canvas and put it
Okay.
in your document at the same time. It'll upload it and put it in your document at the same time.
I noticed when I put it in that it goes in as a PNG or PFG or something like that. Anyway, and then they have to click on it to open it up and look at it. I wanted it to be able to see it right away. No?
Oh, okay. I don't know. I haven't done that yet.
Well, okay. I mean, I've done it where you copy and paste, but then when it goes in, when you upload it, it goes in as I think a .png, not sure.
Yeah.
I might be a little off on that.
No.
And then
Well, here, here's-
when you view it, yeah, there you go. And then they have to click on it in order to open it up in a new window.
Oh, well, it should be right in. Well, let's just update the question. See, I was going to do
Okay.
See, this seems like it's right in there.
Yeah, I know. Sometimes that's what I notice is that sometimes it goes in and other times it won't. And I don't know why.
Okay. Yeah, see,
Yeah.
I was doing this ethylene. I was showing typesetting this.
Oh, okay.
chemistry thing.
Right?
And
I understand that.
yeah.
I was talking about like if you see a car going in traffic and then you have another graph where it's a bus making stops or you have oh gosh, I forgot the other one. Oh yeah, a car increasing speed with no traffic.
There we go. Okay, so
Yeah, that's another one, but I was
save
talking
image
about the
as,
graph. I do a matching with a graph.
okay. But there we go, cars, save.
Right.
Then, whoop,
Now, are you saving to the share? Is that what you're doing?
no, I just saved it to my downloads for the moment.
Okay. All right.
Okay, and now I'll click image.
Right.
I'll go to Canvas,
Oh, okay.
and then I'll click, say, My Files, Upload Files.
Good. Oh, there. Yeah. Uh-huh.
Cars.
Right. And open. Okay. Right.
And it looks like it looks like it's right in there. Well, let's save it and see what happens.
Okay. Update the question. Yeah, so it's in there. Okay.
So
Okay.
maybe you want to go through this laborious process here rather than like dragging and dropping it in or something.
Yeah. Okay. I'll play with it. Thank you.
Yep. All right, good. Anything
Thanks
else?
for a matching question.
All right, I'll save it.
This has been wonderful, Walter. Thank you so much, because I've
Yes,
been trying to
thank
do
you.
formulas and it's a headache. So you make it look easy.
Yeah, it's really nice. Right.
Yeah. If we could get this on the CTLE site, that would be fantastic. Or in the
Yeah.
comments or something, yeah.
Yep, you can always send me questions to email me, or once you're a graduate here of the workshop, you can always email me with the questions.
Okay,
Thank you.
Okay.
Yeah.
excellent.
Email at walter.kewap,
Kehowski, K-H-O,
KEHOWSKI at gcc.edu.
GCCAZ.edu.
GCC as in
Glenda, and Glenn or Glenda.
Glendale. GCC dot AZ
.edu.
.edu. Okay, I got it. Thank you.
Yep.
This has been great. Thank you. And we'll get something as in the email or on Canvas. Do I look for it?
I'm not exactly sure what happens after this. If you don't hear anything, you can always send a gentle inquiry over to CTLE about what's going on.
CTLE.
I think at gccaz.edu also, same.
At gcc.az.edu.
No, it's not a dot. It's just gccaz.
Oh, okay, not a dot.
Yeah, just gccaz.
gccaz.du. Is that correct?
Right.
Oh, good. All right, I got it. Thank you. I just worked on 6 of my tests, and now I got to rework them. But that's okay. That's okay. It's for the fall, so it's
Before we
fine.
close off, you want to hear a little story? I gave a final exam on Monday, and it turned out that it started off for 5 questions, and it had the last few in the middle was blank, and I must have deleted. I was exporting and moving exams around. I must have deleted the wrong one, and they got like to the 5th question, and the whole middle was blank. Didn't have any answers.
Oh. Everything is a learning experience.
That's right.
I had to redo a whole new
Well, I'm glad it doesn't just happen to me.
Yep, I had to do a whole new exam.
Oh well, yeah. I've had to redo my quizzes several times. Once I gave them out, and they said, "Oh well, this wasn't there, or that wasn't there, or the graph they couldn't see, or whatever." Yeah. So I'm working on it. But thank you. This has been great.
Okay.
Okay, thank
Bye
you.
now.
Bye now.
Bye now. Thank you.
Bye. And I guess we're ending. Okay. Bye, everyone.